Hello friends, today I am going to discuss some prestigious topics, and this is GDP analysis. So let's see here. Just I have taken data more than 200 countries, and you can collect the data from like World Bank datasets and other government organizations also. And there is need to the import the some libraries, like just we have already discussed about a library. So most of the library, I think you are friendly with this library. So let's see the import numpy as a np. This is the linear algebra. Import pandas as a pd for data processing, like you can import like a csv data. And from a matplotlib import a pyplot as plt for data plots. And next is the importer seaborn as sns pt data plots and sns.sit. And after that we, uh, if you want to the label and normalize this data, so from sklearn.preprocessing import a label encoder, and from sklearn.middle model underscore selections import a train test splits underscore, right? So for the splitting a data into the train and test subsets, from sklearn.linear underscore model import a linear regressions for using a linear regressions model. From sklearn.matrices import mean underscore square underscore error and mean underscore square underscore log underscore error. So import OS and operating systems OS here, and now you can print your data like this. So overview, you can see the data.pandas as a library and .read underscore csv. I have gotten a data, print the number of the missing data. So you could see, and the print the data is null as a sum, and data describe including. So we need to do all these things here. So could see here like the number of the missings, like countries, like regions, populations, area, pop dot density, coastal lines, needs. So each and everything you could see in this data. Let's see the another thing, just means it's a data types in integer 64. And next you could see here the head of this data, like a country, regions, these are the columns, populations, area, and this has been given. So you could, and you can do this one. So you could see the more columns like this. Okay, so these are the columns of in this data. So look here, already literacy, phones, and arrables, crops, others, climates, birth rates, death rates, agriculture, industry, service. So each and everything, just you can understand the data like this. So I hope now you are comfortable to understand. And after that we are going data preparations. So let's see, in this data we have seen here there are some missing data in a table. So none you have seen in this data. So for simplicity we will just fit the missing data using the median for of the regions, and that the country belongs as the countries that are close and geologically are often similar in the many ways. So for example, let's check the region median of a GDP, like dollars per capita, literacy as a percentage, agricultures, and note that the climates we use a more instance the median, as it seems the climate is a categorical features. So data dot group by we are taking as a regions. So regions and with like a GDP per capita, literacy rate and agricultures, and I need to get a as a median. So the all medians we have gotten like a this one, ECRs and ballistics CW of the Indian states and Eastern Europe's Latin. So it's a like a regions. These are the name of these countries, and this is the GDP per capita has been given like this here, and literacy rate also we could see, and agricultures. Okay, so these are the only the medians. This is not a okay. And similarly, if you want to the fill the missing value, so we need to the write the some algorithms for we are using like a for loops for column col call in data dot columns dot value, and if data columns is null dot sum parenthesis will equal to 0 continue. If call equal to climates, guess value data groups regions and climate dot apply lambda functions here. So lambda x colon x dot mode dot max, else the guess underscore values will equal to a data dot group by region column dot medians, and for a region in a data regions dot unique parenthesis and data column dot ilog data column dot is null parenthesis and data regions and guess a value. So these are the code, so I think you can easily write. After that we will see here, you could see the data exploration. So the like a top countries with the highest GDP. So look at the top 20 countries, the highest GDP per capita, like Luxembourg is a quite ahead. In the next 19 countries are the close to each other. Germany the 20th and 2.5 times the GDP per capita in the world average. So we can see here like a fig, we are using here the matplotlib. AX will equal to PLT dot subplots figure size like 16 point. You can increase and decrease, doesn't matter, and figure. So top GDP countries data dot sort underscore value GDP per capita ascending orders and false dot head 20. We need to see only the 20. Mean will equal to the panda, and just we can get a mean like and panda dot data frame as a countries, and countries we can create like a countries and world mean and GDP per capita data and GDP dollars per capita and mean we can also get here, and GDP's pandas dot concat means concatenate we can add it here the top GDP countries and country GDP per capita and mean here ignore index 2, and SNS like a seaborn dot bar plots. We could like to see here the bar plots, and x will equal to country, y will equal to GDP per capita as a y-axis. It can represent like a GDP per capita and data as a GDPs, and plat is set 3. So AX dot set the labels. AX, if you are not getting the labels, so I have already the number of the videos, so you can see the how to label your data, and dot get x underscore x label parenthesis x label pad 15, and similarly the x y label ax dot set underscore y label and parenthesis ax dot get underscore y label parenthesis comma x label pad will equal to 30, and ax dot x axis dot label dot set underscore font size 16, and similarly if you want to the y labels font size, so you can write this way, and PLT x ticks rotations 90 degree and PLT show. So let's see after that. You could see here very beautiful histograms has been seen like this, and you could see here the per capita. We will see here this country like incomes is the greatest, and second position is the United States, third is the Norway, and fourth is Bremo, Bermuda. Okay, so you can see according to like a per capita incomes. So exactly we are not here, so don't worry, but I think we will reach very soon big 20. Okay, so don't worry, so we are trying hard, so I think we must be reach very soon. So now the next correlations between a variables. So let's see the correlations. We need to the minimum 2 columns. So here I am going to the create here the heat maps and plt dot figure size, and SNS is the very good library to understand the C word. So you could see here the SNS. So you can see according to the populations, and it's the first row. We can see the populations, areas, pop density, constituents of the net migrations instance. So GDP, per capita, literacy, phones, all numeric. Most of the numeric value has been correlated like a arrables, crops, others, climates. Okay, so it's a very beautiful way we can understand your correlations. What is the correlations between? So look here. So if you do not understand the correlations, I have already discussed the correlations. Correlations means there are the one is the positive correlations, another is the negative correlations. If you are near about like a 1 plus 1, so this is the positive correlations, and if you are like a minus 1 is the negative correlations. Similarly, the top factor affecting the GDP we want to see here. So we pick the 6 columns in the mostly correlated of a GDP per capita and make a scattered plots. The result agree with our common sense, and also we noticed there are the many countries with a low average GDP and few with a high average GDP. So like the figure, like axis will equal to plt dot subplots, number of rows has been given and number of columns means 3 rows and 3 columns, fixed size the 20 and 12. So plt dot subplots underscore adjusted, and like a height space here the 0.4, and correlations to the GDP pd dot series panda dot series, 4 columns in a data dot columns dot value, like it depends on the rows, and colon if functions we are using here like a colon GDP per capita, and like a columns this one, and we will see here after that we need to understand this code. And because if for I in a range and j is a range, and we could see here very good correlations, we could see like a GDP and phones, GDP and other factors also. So this is the very good way to understand like this way. Another is the country with the low birth rate and low GDP, because and some features like a phones are related to the average GDP is the more exactly your GDP is the growing, your phone each and every market is also growing. So while the others are not, the for example is the high birth rate is usually the means the low GDP per capita, and per the GDP average GDP is the low birth rate countries can vary a lot. So let's look at countries the low birth rate means if you want to the compare between the less than the 14% and low GDP per capita is the $10,000 lesser than 10,000. So you could see easily. So let's see in this data we have algorithms. We have taken like a data.ilog data birth rate, and I am going to the comparing less than 14%, and the data, the GDP per capita less than $10,000 income. So we could see here your data, and we can easily understand your data. It's look like this. Next, then after that we will apply the model and training and testing models. So first, the label encoded and categorical features, regions and climates, and it will just use all feature given in the datasets without future engineering. So let's see, LE just the label encoded, and data square brackets region underscore label LE dot fit underscore transform data region, and data climate underscore label LE dot fit underscore transform data and climate, and data dot heat. So this is the country, and we can see each and everything. Next, after that we are using a model like a train test. So we can divide it in the two parts, like a training underscore test split and data, and test underscore size, like a 30% data we are taking as a test and shuffle true, so it couldn't be changed here. So training features like populations, area, square meters and other factors I have already written here. And then the target, the GDP per capita, train underscore X like a training for the features, and train underscore Y like a train and targets, and train underscore Y. So you could see just I am using the linear regressions model after that, because after training and tests we need to apply here the model. So first, because these are values like a numeric value, so we can use like a linear regressions. This is the first model. So model dot feed and the train and test, training the predictions Y like a model, predictions train, and training the predictions the X, and training predictions Y, and panda series I am going to. So we can write your own code, don't worry, it's just you can make it's a very simple way also, don't worry. It's and just RMSE means mean square errors, train mean. So you can use also write the mean square law and mean square error, so we can get easily what is the mean square in the training data sets and train data sets. So X and Y both. After that we will visualize, because most of the time people don't have the time to do, so the visualizations is a very big factor. So you can see the model doing, and we can make a scatter plots of a predicting against a ground truth. The model gives the reasonable predictions, and data points are gathering around the line Y will equal to X. So let's see the training test and testing test, and then we can see here like this is the next linear space I can apply here, and you can see here the predictions. This data has been predicted according to the countries. So and all the data look like this way. And after that we could also see the like a total GDP, and also if you want to need here so top countries. So it also the interesting to look the GDP, which I take a GDP per capita multiplied with the populations. Here is the top 10 country, the highest total GDP, and makes about the 2/3 of a global GDP. So the data and the total underscore GDP and data will equal to this one. So you could apply here these codes, and you can create here like a countries wise GDP and United States like this. So you can, and another is the rank. We can create here the rank 1, rank 2, and rank the total GDP wise like United States and other countries. So in this one is the according to the other factors also. So now this is the old data, so you can't believe it this data. So other is the factor affecting like a GDP as a populations, area, phones. So we can easily agricultures, arable climates, literacy, service, regions, crops. So these are the factors to the affect your GDP also. Comparisons of the top 10. So you can easily compare the finally. You can compare all these countries. So you could see here the agriculture, industry and service by, and you could see the all these countries is doing very well. So as well as their land, according to the land we can understand this is a very good, and like this the India is the fourth number. Okay, so I hope we can understand the very basic to the how to calculate this GDP, and it will be help for everyone. So thank you very much for today. I hope it will be helpful.